Okay. Hello, everybody, and welcome to our last special edition of a Hubble Hangout / JWST and I guess Kepler Hangout too.
And Kepler Hangout too, yes.
At the South by Southwest Gaming Expo here in Austin, Texas. Things are still winding down. It's supposed to be closed now, but people are still milling around. People are still there's still a lot of loud music and stuff like that. So, and as you can see off to the side here, Frank is still talking to some of the public. So I wanted to go ahead and get started because it is, after all, 9 o'clock Eastern time, daylight time now.
Daylight, oh yeah. I slept one less hour today.
Yeah, I know. So with me is Dr. Alberto Conte from Northrop Grumman, my old friend, and you guys know him. We do a lot of these together, and we're going to sit here and talk while we get this thing, while people get kind of settled in, and other people here. We have Natalie Battaglia from
Kepler.
Ames.
NASA Ames.
NASA Ames, right? She's going to show us a new app. Is it an app for Kepler visualization?
It's actually an app for Windows 8. Actually, I don't know if they have some other app, but it's an app for it's a program really that runs on Windows, right?
Right. So we're going to show you some of that we've been showing to the public here because it's a really amazing way to kind of see the number of planets, the number of planet candidates versus rocky planets and things like that. So
didn't realize you guys had started.
Well, we had
Frank.
to start.
I know.
Also with me now is Frank Summers. Well, there were just people around, and so it got to be 9 o'clock, and people were waiting, and I needed to get going.
Go for it.
So anyway, so we're talking about. So Natalie's going to be here. Frank Summers from the Space Telescope Science Institute. Someone's going to show us some of his visualizations. We also have Amber Strawn is still here, and the panel today. You did a panel called First Signs.
First Signs. Finding life on other planets.
Yes.
So
did you find any?
None. Life, I don't know. We found something. We found that it was extremely engaging for everybody. I had a lot of fun personally. So what was your actually? Before we go into this, so we had a panel basically describing a few things. So Natalie, and you might want to bring her here afterwards. I don't know.
Oh, I am.
Actually tell you about
definitely
about Kepler basically.
I got a lot to ask. Natalie, don't you go anywhere. Okay, good. She's walking away.
Amber Strawn talking about JWST. We had Blake Bullock from
there she
Northrop
is.
Grumman.
That's her.
From Northrop Grumman, talking about the James Webb and the engineering, and then I talk about kind of the future. So I don't know if we found life. We found that it was a very, very interesting subject for lots of people. It was very engaging, I thought. We had lots of questions at the end. We had lots of interest in social media about what NASA is doing right now, in order to fulfill that. I call it almost like promise, right? To fulfill that dream that we want to find life on other planets. And I don't know, you were on the receiving end, you were listening to us.
So you, from my perspective, you geared it toward beginners, someone who didn't know anything at all about what was going on with space telescopes. And I'll be honest with you, I've talked with a lot of people out here who have never heard of the Hubble Space Telescope. I asked them, do you know what Hubble is? They're like, no. So telling them what JWST is almost, not worth it. You got to first start with what Hubble does. So I know why you had to do that.
Yeah.
And so you geared a lot of it towards what is a habitable zone, why are we looking for planets with liquid water, why does it matter, things like that. But then toward the end, I thought you had, and I'm not saying this because you're standing next to me, because I can take you any day, so I'm not afraid of you.
Absolutely. Neither am I. Let's go.
But no, I thought some of the most interesting stuff was the slides you showed about what looking beyond JWST. How scalable are space telescopes?
Right.
Building Hubble was one thing. It was constrained by the space shuttle. It had to fit in the space shuttle cargo bay. The James Webb Space Telescope is being launched on an Ariane rocket, one of the biggest we could find. This is pushing it. So if we want to build a bigger telescope than this,
how are we going to do it?
Yeah, I mean, it's one thing to build gigantic primaries, but does this thing scale? Can you launch larger space telescopes?
I guess my point in all that discussion was that, and you know this very well, astronomers are not going to stop at James Webb.
No,
right?
Of course not. They got to think about the next thing.
They're going to find the next thing. They need to think about the next science that they can do once Webb launches, because we know they're going to make amazing discoveries. And so part of it is, what are we going to do in terms of being able to launch this structure? And I think I try to hammer the point that the fact that we're building Webb is the necessary step to understand how large deployable structures can be really delivered, to a million miles away, to fit, to second Lagrangian point to operate. And I think to some extent NASA is putting forward a roadmap for the next 30 years to figure out exactly where we want to go with this in terms of the science. What are the science drivers, right?
Right.
What are the science drivers? Why do you want a much larger telescope. And I think this is a very, very healthy discussion we're going to have, and it's a discussion that we're going to have over the next few years, because
well, more like next few decades, because this is
and the next few decades.
This is a hard problem to solve.
It's a very hard problem to solve. I agree.
Another interesting point in the panel, and I don't know if it was Blake that said it or Amber, but it was about this. This quote. One of the most often asked questions about JWST is what happens when a micrometeorite, you send it out to L2.
Yeah.
And what happens if micrometeorites pummel it to death, or what if something hits it? And the point is that the L2 point is actually a relatively unstable point gravitationally.
Correct.
Things don't want to stay there of their own accord. So it's actually a pretty clear area. It's actually a pretty safe zone to put a spacecraft, because anything that would happen by would not tend to want to stick around and hit JWST.
Correct.
So I think
it's a relatively clean place.
It's a clean place. It's a possibility, but I don't think it's a real huge danger, in large part because of the spot where it's going to be put. We'll talk about this some more, but I want to get right away into, now it's kind of clearing out a little bit.
Yeah,
Natalie, can I bring you over here for just a sec? So with me is Dr. Natalie Battaglia from the Kepler mission. Hi, it's good to see you again. You have brought a really cool thing for us to look at that I am dying to show people. Would you step us through? I'm going to just put you over here by the
Sure.
monitor. I'm going to move the camera. And is this too unwieldy for you to hold?
I can try. I might accidentally rip it off the computer, but I can try.
Okay, so yeah, I'll hold it for you. Let me go move the camera a little bit so that you're centered, and then we will move. Very high tech operation.
So while you're doing that, can I just explain a little bit of what it's about? So this is a brand new app. Not an app, it's a visualization tool to visualize the Kepler discoveries. It's brand new. This is kind of a sneak peek. Hopefully soon it will be released to the public, so the public can play around with it. But for now, anyway, it's kind of a work in progress. Consider it to be a beta version. It still has some kinks, but
so you're saying people will be able to get this and play with it?
I believe so eventually. That's the idea.
Oh, yeah. Great. Okay, great.
Yeah. So anyway, I'll step you through it.
All right. I'll try to move the mic so she can be heard.
Oh gosh, can people hear? Is there anybody online that can give us feedback? Okay. So
I can tell by the indicators. So.
Okay, I'm going to stand on this side so I can have volume. What happened? Okay. Sky map. All right. So I start with. Actually, I'm just going to hold it. So here we've got a sky map of the Kepler field of view. This is the patch of sky where the Kepler has been targeting over the last 4 years to find exoplanets, potentially habitable Earth-sized exoplanets. It's about the size of my open hand, projected or held out at arm's length on the sky between the constellations of Deneb and Vega. Deneb and Cygnus, the Swan, and Lyra. Deneb is one of the brighter stars of Cygnus, and Vega is the brightest star of Lyra. And our field of view is nestled kind of underneath the wing of Cygnus the Swan right here. So every square that you see is one of the CCD detectors that measures brightnesses of these stars. This is near the plane of the galaxy, so there are literally millions of stars in that one footprint on the sky, and Kepler has been monitoring about 150,000 of those stars. So over here you see let's see, data, the total counts of planets. So Kepler has now discovered over 3,800 planets orbiting other stars, associated with about 2,961 stars. So lots of these planets are orbiting the same star. We have multiple systems, multi-planet systems. So Kepler's not just discovering planets, it's discovering planetary systems. And that can be visualized really well looking at the orrery view. So here you see laid out all of the stars. Well, the stars themselves are not shown, only the planets that are orbiting them. That's what's shown depicted with these circles, and you see them moving in their orbits at the correct orbital period, at the correct relative orbital period. In this case, time has been significantly sped up. The size of the circle is scaled to the actual relative sizes of the planets. So we see circles that are 10 times larger than Jupiter, the gas giant in our solar system, all the way down to things that are half the size of an Earth, maybe the size of a Mercury. So right now we're displaying all of the systems, all 3,864 planets around the 2,961 systems. And so we can scroll and we can look at them. Here you have a 3-planet system. I can actually limit it to multi-planet systems by clicking this button. Here we've got a 4-planet system, 4, 3, 2. Kepler has found 5, even 6, even now 7 planet systems. Each planet contributing its own periodic sequence of little diminutions of light. So I can tell you that about 85% of what you're seeing here, if I go back to the whole entire sample, I have about 85% confidence that any one of these is actually a true planetary system. If you wanted to see those that have a higher than 99.7% confidence level, then I can click just the confirmed planets. Of the sample of about 4,000 planets, Kepler has confirmed approximately 1,000 of them now. So that's what you're seeing here. Actually 961 confirmed planets, and you're seeing them in the Aura review. I can now limit this by the temperature, the surface, the equilibrium temperature of the planet, to try and isolate those that are in the Goldilocks zone. So I'm going to press this button here, habitable zone, zoom down. So these are the really valuable planets. These are the systems. Let's see. These are only the confirmed planets. So we have a larger than 99.7% probability that these are bona fide planets, and they're in the habitable zone. All of these. So the tool is telling me that there are 19 planets associated with 17 systems. I'm not certain that not sure that actually makes sense. So I don't know, I'm a little bit perplexed. That doesn't look like 17 to me, but anyway, these are our habitable zone planets. I can click on any one and get the actual name of that system. KOI 518, here I've got a 5-planet system. KOI 701. 701, KOI stands for Kepler Object of Interest. So as soon as we find a system that has indications of transits that are consistent with planets, it's given a number, a KOI number, Kepler Object of Interest. So for example, KOI 701 is now a confirmed planetary system, so it was also given a Kepler number. That is the Kepler 62 system. That has 2 confirmed planets in the habitable zone. Kepler 62 E and F are the green and blue outer planets. That blue one in the outermost orbit is just 40% larger than our own planet Earth. So we have a very high confidence that that is actually a rocky planet, and Kepler 62F is right smack in the middle of the habitable zone of that K-type star. So that's probably my favorite planetary system that Kepler has discovered so far. So I don't know, there's more I can tell you about the app. There are lots of different things you can plot, but basically that's it in a nutshell.
Let me move the camera back a little bit.
There we go.
Okay, so this app you say will be available this will be a Windows kind of thing, or?
Yeah, that's a good question. I mean, right now
They're
it's
still
running on
developing
a
it?
Windows system. It also
Right.
runs on Mac. It's pretty independent.
Yeah, this is Windows 8 that it's running on. So
yeah, but it's not an app like an app for a phone. It's a visualization.
Sure. And so let's get to that. So all of the Kepler data so far of all of the candidates versus the confirmed planets, all of that, even the stuff up to last month. But I believe you did a big announcement last month.
715 newly
That's
verified
right.
planets last week.
Yes, that's right.
Yeah.
I did a Spaceman News on
Right.
that. So okay, so So we'll keep an eye out for when this is going to be available. But I have two questions that I'd like to ask you. Number one is about last week. How come all of a sudden we can go from, they're still gaming. How come we can go from all of a sudden to have all these candidates for you to just go straight to calling them exoplanets now? Tell us the technique that makes it all of it, because if you look at the graph of all of the confirmed exoplanets, all of a sudden it spikes in February.
It spiked a lot. It
right.
Almost doubled. Yeah.
That's right. So what's different? Explain that, because I'm still trying to get my head around that.
So these are objects that we've discovered over the years. So we've known
These were
about
candidates
them.
before.
Yeah, they were candidates before. But now we've got this logic of probability that's been applied to this particular sample. I can give you an analogy. Let's say that you had 1,000 people and you were going to tell them to go into a big football stadium, and they were going to sit completely randomly in random seats in this stadium. Because the stadium is so big, there's not a very high probability that any two people would be sitting next to one another. Right?
Well, how many people? You mean
just like 1,000
people?
You mean
a small? Okay, compared to the number of seats.
Yeah, exactly.
Okay,
compared
got
to
it.
the number of seats. So
Got
there's
it.
not a high probability that you'd have two people.
So 1,000 people in a 70,000 seat stadium.
Yes.
Chances are very small they're going to get any two people sitting together.
Exactly. But you go to the stadium and you observe something different. You observe people sitting in groups. And so what do you conclude? You conclude that those people sitting in groups, they know each other, right?
Mm-hmm.
They came together.
Or they've got some kind of strange herd mentality that you don't really want to know about.
So that's the kind of logic. It's a simplistic way of making an analogy to the logic.
Okay, that makes sense.
So these are our multiple planet systems.
Okay.
You know, there are astrophysical things in nature that can confound us, right? We have, like I said, an 85 to 90% confidence level that all of these are planets. But if you really want that 99.7% confidence level, this is the sample that has that kind of a confidence because of the multiplicity. It's just the odds of that happening are too small.
So because everything left to its own devices, randomly distributed planets would not be in a system. And yet Kepler doesn't see that. Kepler is seeing a lot of clumps together of hundreds, and so
like thousands.
So they can't be stars because they don't clump that way.
Exactly.
They must be planets. And so you're saying with 99% certainty that these are now planets. And so that greatly expedites this candidate, to confirmed.
Yeah, Jack Lissauer, one of the leaders of this study, he said this is planet verification wholesale. We're getting planets wholesale.
Good, but yeah, exactly. You go see, that's right. Cut out the middleman, right?
Cut out the middleman.
Who needs ground-based telescopes? Yeah. I'm kidding. I'm just kidding. We need ground-based telescopes.
We do. We want the masses of all of these planets one day. We want to know what their atmospheres are. But for now, what's important, using ground-based telescopes is very expensive. Yeah. Right?
Yeah.
So it's much better
space telescopes.
If I can tell you, what are you going to use your 5 nights on the Keck telescope for? If I can say I've got a planet here that has a 99.7% probability of being a true planet, and over here I've got one that has an 85% probability. Which one are you going to choose?
Yeah, exactly. You're going with the lower probability. Yeah. So that makes sense. Well, that's better than the analogy they used in the press release, which was about lions and lionesses.
That was
I scratched my head. So lions are stars and lionesses are planets.
Oh, don't go there.
Don't go there.
La, 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 la,
hey, I didn't write it.
Me either.
And that's why I'm trying to go, okay, well, I'll use that analogy then. But so this is a better one. I liked yours much better. So thank you. One more thing. Today at the panel, you said something that blew my mind, and I want to clarify. I want to talk about this a little bit. But no, people are really interested in the status of the Kepler telescope.
Okay.
I mean, we're all sad that the momentum wheels have died on those, and that it's not able to continue. It's not accurately pointing. It's not able to accurately point enough to continue to try to find these planets
in that particular field of view.
In that particular field of view.
Yeah.
Good. Well, we'll get to that too. Okay, good. And then you said, well, wait a minute. The engineers have come up with a way to use solar radiation pressure to basically act such that it has a momentum wheel that it wouldn't have had before.
Yeah.
Now, does that mean it'll be pointing in a different area of the sky?
Exactly. That's right.
What is that area?
So the ecliptic. So it's along the orbital plane.
That's the plane of where the Earth follows around the sun.
Yeah, you have these 3 axes of rotation that have to be stabilized, right?
Right.
But we've only got 2 gyroscopes. So we're going to take that 3rd axis, and luckily, the spacecraft has a symmetry axis, okay?
Meaning that it spins around
Meaning that geometrically it's a symmetric shape.
Oh, okay.
Okay, so
that's the longitudinal axis, right?
So if we take that side of the telescope and we face it towards the sun, it's like taking a canoe and pointing it perfectly upstream.
Okay,
right?
I get that. It's like a wind vane.
Yeah, because
also.
the canoe is perfectly symmetric. The oncoming water is going to push equally on all sides of the canoe.
Okay.
And that's what we're going to do with the telescope. We're going to take that symmetric side and face it towards the sun. The solar pressure pushes on it, but it does so in a balanced way that controls that third axis.
And that's accurate enough to be able to look at it in the new patch of sky. And so it's anywhere along the ecliptic.
Anywhere along the
So it'll be sweeping a path across as it does its orbit around the sun.
That's exactly right.
So who knows? I mean,
Yeah.
way more than a. I mean, I know why you stared at Cygnus. I mean, you wanted to get deep image. You wanted to get a lot of
we
time.
want to get statistics.
That's right. And you wanted to get time data, right? A lot of
absolutely.
a lot of light
4
curves.
years. We
a lot
wanted
of
to be
light
sensitive
curves.
to Earth analogs,
Right.
and we wanted to get statistics, so lots of planets.
So what do you? I know you said they're going to decide on this in April, on April Fool's Day. They're going to NASA. Will NASA decide, or
that's when our presentation is to the senior review panel, the
Oh,
Astrophysics
okay.
senior review.
Oh, okay.
Our presentation is on April 1st,
okay?
and see how excited they are.
Yeah, I told you, Kepler.
Yay, Kepler! So then we'll hear by the end of May whether or not NASA can fund it.
Okay.
So,
All right. So I'm sorry. The end of May, you said.
around the end of May, beginning
Okay.
of June,
Oh,
somewhere
okay.
around there. Yeah.
Well, I don't know. I know that they've got proposals out, and they got people thinking about what else to use Kepler for.
Oh my gosh.
You know, in its current state.
Yeah.
And that's great that they're thinking along not wasting Kepler and to continue to use it.
Yeah,
but
it's
I don't think,
really
without a
quite
doubt,
exciting.
there's anybody out there that would love to see it continue to try to find exoplanets in whatever capacity.
Oh, all kinds of science.
Yeah.
People are proposing to do amazing things with the telescope.
Yeah.
All kinds of stellar astrophysics, galaxies, supernovae, microlensing, all kinds
So
of stuff.
essentially, you've got one proposal among others of all these others, and then NASA
That's
will
right.
sift through all those and decide.
Well, no. I mean, if Kepler,
Or do you have priority?
if NASA, no. This is a community telescope. It's going to be open to the community. We are not choosing any of the targets.
Oh, okay.
The community is going to choose all of the targets. But of course, exoplanets is one of the most hot topics, right? So lots of people
I
are
see.
proposing
Oh,
to
I
do
see what you're saying.
exoplanets.
All
Yeah,
right, so
but-
this is one of many things it could still do, and now that you can point it with that longitudinal axis
Exactly.
away from the sun.
That's
Okay.
right. Yep.
All right, well, that blew me away, and I was so happy to hear that. So thank you
Oh,
very
good.
much, Natalie. I appreciate
glad.
it. Thank you for taking time out to talk to us and show us this stuff.
Thank you for
I
having
hope
me.
I can
It's
get
been a
Frank.
pleasure.
Did he leave? Okay. All
Frank
right.
is right here.
Sorry. So thank you.
You're
That was
on,
Natalie
guy.
Talia from the Kepler Space Mission.
Bye-bye, guys.
And bye-bye. Thank you.
Where do you want me?
Why don't you stand over here, because you're going to be over there soon. I'm going to have to move the camera. So one of the things that we've been trying to do out here at South by at the Gaming Expo is to get the word out, not just about JWST, but and with Kepler, but also about some new things from Hubble, and most notably, Hubble still, after almost 25 years, which, by the way, well, actually, its 24th anniversary is next month.
24th anniversary next month.
24
Although,
years.
I gotta tell you, secret for just you guys who are watching us, we're actually going to release the 24th anniversary image this month. Okay, there's this big conference in Rome, and we're going to release the 24th anniversary image a month early, although we'll do some cool stuff for the 24th anniversary. All right, but yes, Hubble's 24th anniversary, and in, 14 months? Yeah, 13,
Yep.
14 months, we'll have Hubble's 25th anniversary, which would be a really cool event. You imagine all the cool stuff we got planned for that.
Not bad for a telescope designed to work for 5 years. I mean, that's pretty good.
I think it was 10 years, but
Oh, was it 10?
whatever.
Okay.
I think Hubble's original goal was 10 years. Okay, but I wasn't around back then.
And
I
we're
wasn't
going to be
in the
pushing.
project
I
back
think.
then.
I think they're going to be pushing for 30 on this one by the time it's all over.
I certainly hope we're going to make 30.
There is some designed overlap between Hubble and JWST going forward, so that'll be an exciting time to have both telescopes up at the same time. So
You bet.
let's hope that all works out the way it is. So Frank has, over the course of the last, not just year, but over more than that, right? A couple of years, you've been working on a lot of different visualizations of all kinds of different things.
Yeah,
right?
I've been working on visualizations since I did my PhD thesis back in 1993, and my first really big visualization was working on the IMAX film Cosmic Voyage in 1996. So I've been developing my skills, moving from an astronomer who does data visualization, right? I mean, things to do for my PhD thesis. I was just trying to do data visualization to understand what's going on in these computer simulations. And then when I started doing the IMAX, we worked in the IMAX film, I learned about how to take that and turn it into what we call cinematic scientific visualizations, where it speaks not only to the geek astronomers, but also starts to speak to the general public, taking real data from Hubble, real data from these simulations, and expressing it in ways that the public really can embrace as well.
So why don't you show us some of the things you've been showing the public here? And I'm going to go move the camera.
You move the camera.
Oh, and when you're talking, if you could hold this when you get set up, I'd appreciate it, like Natalie did, so we can hear you.
All right. So, holding the big microphone. Cool. All right, so I'm going to show you a couple of the visualizations that we were showing off. Now, these are visualizations that we have done for Hubble press releases. And the first one, you can see the title here, is Crash of the Titans, Milky Way and Andromeda Collision. Now, we have known for, decades, about 100 years, we have known that Andromeda is headed towards the Milky Way. But it wasn't until just 2 years ago or a year and a half ago that Hubble was able to measure the sideways motion of Andromeda. And so we know that it's coming towards us, but if it's moving sideways a lot, then it might circle around the Milky Way. All right, but Hubble was able to make an ultra-fine and ultra-precise measurement. I mean, measurements down to 7/1000ths of a pixel in terms of the motions of stars to measure the sideways motion of Andromeda. And so based upon those observations, we're able to tell the true 3D space motion of Andromeda relative to the Milky Way, and it turns out that the trajectory is consistent with a head-on collision. Now, that's something really cool, right? So we figured, all right, we have to show that in our press release. And so we created this visualization with some folks up at Columbia University and Harvard University and Roland van der Marel, the Space Telescope Science Institute. So you'll see that the visualization starts with our Milky Way galaxy, and for the first billion years, not much is happening, so we focus on the Milky Way, and then pull back and show you the Andromeda galaxy, the other large galaxy in our local group, and the Triangulum galaxy, which is sort of the one medium-sized galaxy in our local group. These are the three big galaxies. And then the camera swings around so you can see how thin the Andromeda galaxy is, and about 3.9 billion years from now, the Andromeda and Milky Way galaxies are smashing through one another, right? They go smashing through one another. The Triangulum galaxy is orbiting around them, but they become gravitationally bound and they come smashing back together, mixed together, and about 5.5 billion years from now, the Milky Way and Andromeda will be one galaxy. They will have merged together to become a single galaxy. Now, in most of the versions of this simulation, most of the versions that they tested when they varied the parameters, the Triangulum galaxy stays outside of it. But in 10% of them, the Triangulum galaxy actually merges with Andromeda and the Milky Way. So in some of the cases, actually all three of the big galaxies in the local group become one galaxy about 5 or 6 billion years from now. And that's that's one of the visualizations we've been showing here. We actually have an entire list of about 30 different visualizations that we've been showing off while we're here. Do we want to chat on something, or do you want me to try and... Oh, all right, hold on. Okay. Let me just go ahead and play the next one that's in the list. I don't know. All right, I'll pause that there. All right, we've got a playlist up here. I actually don't have the playlist memorized, so I don't know what's going up. But you can see we've got these title screens for us. So this one is a really nice one that shows how multi-wavelength astronomy really works together. So this is the active galaxy Hercules A. And it's called Hercules A because it is the brightest radio source in the constellation of Hercules. Cassiopeia A, Cygnus A, Sagittarius A are similar things that are the brightest radio sources in their constellations. So active galaxy Hercules A, when you see it in a Hubble image, isn't actually as impressive as you might think. All right, it is a giant elliptical galaxy. All right, and this galaxy is about 10 times the mass of our Milky Way galaxy. All right, and so it's a giant elliptical galaxy, but it looks a lot like other giant elliptical galaxies, and so thinking of it as the most powerful radio source, doesn't really show up in this image. So we're going to play the visualization for a little bit as we pull back from the galaxy to show the group of galaxies around it. Now, this galaxy, these giant elliptical galaxies, generally are in these large clusters of galaxies that have hundreds to thousands of galaxies. And this one seems to be in a relatively small cluster of galaxies containing just dozens of galaxies. And it's kind of strange. But what really makes this interesting is that there is a supermassive black hole at the center of this giant elliptical galaxy. And that supermassive black hole has intense emission that streams across not just interstellar space, but actually across the entire galaxy and across intergalactic space. You can't see that emission in Hubble's observations, but you can see it in the radio observations. And so what we're going to do is we're going to take this model of the Hubble observations and we're going to superimpose on it in 3 dimensions the radio observations from the Very Large Array. So if I continue the observations, the visualization, you can see these pink radio lobes. And while the galaxy extends hundreds of thousands of light years across, these radio lobes actually extend about 1 million light years across, not just interstellar space, but actually intergalactic space. And this is one of the visualizations we did that we actually did in stereo 3D. So as we rotate these lobes, you can actually see this lobe over here on the right coming towards you. So those are 2 of the visualizations that we've been showing here. We've got about 30 more. And what we're really doing is we're showing off that we've got a new web page on Hubble site, where we are featuring these videos. And of course, we're featuring them on our YouTube channel, Hubble site channel as well. So we have put up, there we go. Go ahead. We have put up a brand new web page at hubblesite.org/videos that we've got, what have we got, about 20 of them there by now?
I don't know how many. You put up a lot, I know that.
We've got about 18 of them there, 5 of which are stereo 3D. So if you own a stereo 3D TV at home, you can download them and play them on the TV and put your glasses on and go, oh wow, I'm cruising through the 3D universe on your living room couch, which is kind of cool. And we'll be adding new ones about once every other week for the foreseeable future, because we have a whole backlog that we're going through. We're processing them, we're putting them out there at full HD, 1920 by 1080. We've got them in QuickTime, we've got them in WebM, the HTML5 codec, and even in Windows Media. So we try and hit you and give you all the cool things in all the different varieties of the ways that you guys want them.
Yeah, and I know a lot of you are watching them because I was showing you the views today. The YouTube channel has spiked in views to almost about 3 times normal. So you guys are watching them, and these are downloadable. For me, the way I look at it, Frank, is this is all new material for me to start making videos with. So I thank you for all this effort. No, it is impressive. Hubble continues to amaze and to give us great material even after all these years. So thank you for your efforts, Frank. I really appreciate it.
I just want to echo your comment there, is that, I mean, Hubble may be 24 years old, but we had a service commission in 2009 that rejuvenated it, and, you know, it's still at it's still at the peak of its powers, okay? It is not old and creaky and tattered and worn. It is still a viable Hubble instrument, and astronomers still really want to get time on it. It's totally oversubscribed. So Hubble is got many good years left in it.
That's right. So with us, come around this side and stand over next to Frank. So next we have Christina Thompson from Northrop Grumman. She's the way more. I don't want to just call you like the press person, because it's like you do so much more. You were like in charge of everything last year, and this year you're like, you know, still getting us all lined up and ready and saying the right things and doing the right things.
Thank you.
And also Dr. Bonnie Meinke from yesterday. You remember her? She's a OPO outreach scientist. So these outreach efforts from Northrop Grumman's perspective, is this something you guys do a lot of, or is JWST kind of special in that way?
No, we definitely do a lot of outreach at Northrop Grumman, but the James Webb Space Telescope is the perfect program for us. We say that it's leading the next generation into space. and it's the perfect program to be able to go out to the public and talk with people, inspire young kids to get interested in science and technology. So it's really kind of a treat for us to come to events like this because people are so curious about the Webb telescope and they just want to know more. So it's kind of a great way to connect with people and bring science out to the public.
What about the people that work at Grumman? I mean, do you feel a sense that the employees have a sense of pride in what they're doing? Or I mean, I know that if I worked there, it'd be like, hey, I'm working on near camera, I'm working on the backplane, or I'm working on the mirror segments or whatever. I'd be like going crazy.
Yeah, I think so. I mean, I walk around the halls and people are excited to be building something for NASA. It's kind of a very cool thing to be able to say that we're helping NASA to build the next telescope to be the successor to the Hubble. I mean, it's not every day that you get to go to work and work on something that'll actually revolutionize the way we understand our universe.
I know. I say the same thing about where I work. It's like the Hubble Space Telescope. Yeah, I'll be glad to spread the word on that. It's an easy job. So, well, what was your impression here of this gaming expo? I mean, I know that last year we had a bigger footprint here. We had the main model and thing. We had a much scaled down version this time, but I don't know. I felt like we saw quite a few people, didn't you?
I did. I thought that it was really a great experience because people were, innately interested in science. People who are interested in gaming tend to be, curious about what else is out there.
At least they were receptive. Yeah.
Yeah, the idea of fantasy or thinking about things other than the here and now. So I thought it was a great way to just kind of connect in with this culture, kind of a different venue than we would normally go to at Northrop Grumman, but it's definitely a way for us to reach a new and younger audience, I think.
That's a good point, yeah. So we were talking earlier today, I think Northrop Grumman and the Institute, I think with these Hangouts, we're going to look and try to make an effort over the coming year to do a little bit more integration with getting some more of the Northrop engineers involved and getting some. We talked to the chief engineer yesterday. He was an outstanding person to have around. I mean, what a source of information. So I think we can look forward to some of that kind of collaboration.
Yeah, absolutely.
Great. All right. Well, thank you, Christina.
Yeah,
Thanks for
all right. Go ahead.
Bonnie, I know we got to start tearing down, but I had to talk to you.
Okay.
Yeah, I just.
We can't tear down till the crates are here, so it doesn't even matter.
Oh, that's right. We got to wait. That's a good point. Okay. Bonnie has been tireless in this weekend and getting things going. I don't know. What are your impressions?
It's not tireless. I'm pretty tired.
Well, okay. You're now starting. I think we're all getting a little bit long in the tooth here with this. Yeah.
Yes.
So what was your impression? Do you feel like we accomplished our mission here with getting the word out to enough people?
I think so. I think a lot of people came to the booth knowing what Hubble was. Hubble's very much a household name at this point. People know what Hubble is. That was a good entry point for a lot of people. We were able to say, hey, do you know about Hubble? Well, here's the next big thing.
Right.
And that really sparked their interest. Seeing the fantastic mirrors kind of drove it home that this is a big deal. It's huge and fantastic and really important. Telling kids that it was kind of like Transformers once you launch it into space and the whole thing has to deploy.
Yeah.
That really kind of hooked them, I think, in a lot of ways. And I think people left here with a greater understanding of what the James Webb Space Telescope will be, or a better understanding of the science that Hubble has currently accomplished and how that will translate into the Webb era.
Yeah, so I wanted to ask your opinion on something. Today at the panel, there was a question at the end of it. This was the panel that Alberto and those guys did. There was one of the people came up and go, I noticed like there's a gender skew up here, and Alberto was the only guy, right? There was Blake and Amber and Natalie up there with them.
Now he knows what it feels like.
Yeah. And I tweeted that, it was something I've noticed too. I've seen a lot more women in astronomy over the past, maybe 10 years than I had in the previous, 10, even 20 years. And I wanted to get your impression of that. Is that something, do you feel like that's sort of equalizing, or is there still a long way to go as far as the gender issues in astronomy and science?
There's still a ways to go, but You're right. Things are getting better. Things are improving. The climate is improving overall, which makes it easier to enter the field, makes it more friendly to stay around. And so there's, more women in my generation of scientists, and I think the next generations to follow, there will be increasingly more. It's interesting, though, because there's a kind of a sociological phenomenon that happens when women and men, when the percentage of women gets above a certain critical point, and it's usually somewhere in like the 25 to 30% range. People are like, oh, it's equal. So I think we're almost there in astronomy.
Some things are more equal than others.
Yeah, it's definitely not equal yet, but it's to the point where people don't notice that oh, there's no women.
Yeah.
And I have a
20,
feeling, I have a feeling that there's fewer undergraduate women in astronomy now.
Okay.
There's fewer that feel the way that I felt, where you're the only woman in the class. Especially in a large lecture, there's definitely other women there, and even in an upper division in a graduate level class, there's 3-4 other women to do homework with in a class of say 10. Good. So it's a good thing.
Awesome.
It's an awesome thing. Yeah.
Yeah, I wonder what that is. Can you attribute that to anything, or is it just so many factors you just can't really pin it down?
Well, I think in a certain places, certain institutions, universities have adopted certain policies that make it a friendlier climate.
Okay.
And it's that friendlier climate that really makes a difference. So there are some places where there's no women on faculty. That's an unfriendly environment. There's other places that have really made a concerted effort, and we need
to
cumulatively applaud those places.
starting to get there, to get somewhere. Our boxes are starting to show up.
Yay!
So I think I'm going to have to start cutting this short. Did Alberto leave?
Yes.
Oh, okay.
So.
Darn it! I was going to say goodbye.
The sooner the boxes get here, the sooner
I know. When there's work to be done, there's like Alberto is like gone. There's like he's out of here. No.
All the women scared him off.
Yeah, that's true. All right, folks.
Heaven forbid more than 3 women in a room.
Okay, guys. I hope this was helpful to you. I hope you enjoyed this. We'd like to get a chance to do more of these with you. We're going to be collaborating a little bit more with Northrop Grumman over the coming years, like we talked about. Alberto and I have some good ideas for some engineering hangouts coming forward, and I think you'll find those interesting. So, thank you guys for tuning in and supporting us through all this. And we will pick up our Hubble Hangouts probably a little bit later on next month. So, thank you guys for watching, and as always, keep looking up. Settled in and other people here. We have Natalie Battaglia from
Kepler.
Ames.
NASA Ames.
NASA Ames, right? She's going to show us a new app. Is it an app for Kepler visualization?
It's actually an app for Windows 8. Actually, I don't know if they have some other app, but it's an app for it's a program really that runs on Windows, right?
Right. So we're going to show you some of that we've been showing to the public here because it's a really amazing way to kind of see the number of planets, the number of planet candidates versus rocky planets and things like that. So
didn't realize you guys had started.
Well, we hadn't started.
I know.
Also with me now is Frank Summers. Well, there were just people around, and so it got to be 9 o'clock, and people were waiting, and I needed to get going.
Go for it.
So anyway, so we're talking about. So Natalie's going to be here. Frank Summers from the Space Telescope Science Institute. Someone's going to show us some of his visualizations. We also have Amber Strawn is still here, and the panel today. You did a panel called First Signs.
First Signs. Finding life on other planets.
Yes.
So
did you find any?
Not life. I don't know. We found something. We found that it was extremely engaging for everybody. I had a lot of fun personally. So what was your before we go into this? So So we had a panel basically describing a few things. So Natalie, and you might want to bring her here afterwards. I don't know.
Oh, I am.
Should tell you about
definitely
about Kepler basically.
I got a lot to ask. Natalie, don't you go anywhere. Okay, good. She's walking away.
Amber Strawn talked about JWST. We had Blake Pollock from
Northrop
Grumman.
That's her.
From Northrop Grumman, talking about the James Webb and engineering, and then I talk about kind of the future. So I don't know if we found life. We found that it was a very, very.
But then toward the end, I thought you had, and I'm not saying this because you're standing next to me, because I can take you any day, so I'm not afraid of you.
Absolutely. Neither am I. Let's go.
But no, I thought some of the most interesting stuff was the slides you showed about what looking beyond JWST. How scalable are space telescopes?
Right.
Building Hubble was one thing. It was constrained by the space shuttle. It had to fit in the space shuttle cargo bay. The James Webb Space Telescope is being launched on an Ariane rocket, one of the biggest we could find. This is pushing it. So if we want to build a bigger telescope than this,
how are we going to do it?
Yeah, I mean, it's one thing to build gigantic primaries, but does this thing scale? Can you launch larger space telescopes?
I guess my point in all that discussion was that, and you know this very well, astronomers are not going to stop at James.
Okay. Hello, everybody, and welcome to our last special edition of a Hubble Hangout / JWST, and I guess Kepler Hangout too.
Kepler Hangout too, yes.
at the South by Southwest Gaming Expo here in Austin, Texas. Things are still winding down. It's supposed to be closed now, but people are still milling around. People are still there's still a lot of loud music and stuff like that. So, and as you can see off to the side here, Frank is still talking to some of the public. So I wanted to go ahead and get started because it is, after all, 9 o'clock Eastern time, daylight time now.
Daylight, oh yeah. I slept 1 less hour today.
Yeah, I know. So with me is Dr. Alberto Conte from Northrop Grumman, my old friend, and you guys know him. We do a lot of these together, and we're going to sit here and talk while we get this thing, while people get kind of
Interesting subject for lots of people. It was very engaging, I thought. We had lots of questions at the end. We had lots of interest in social media about what NASA is doing right now, in order to fulfill that. I call it almost like promise, right? To fulfill that dream that we want to find life on other planets. And I don't know, you were on the receiving end, you were listening to us.
Yeah, so you, from my perspective, you geared it toward beginners, someone who didn't know anything at all about what was going on with space telescopes. And I'll be honest with you, I've talked with a lot of people out here who have never heard of the Hubble Space Telescope. I asked them, do you know what Hubble is? They're like, no. So telling them what JWST is almost, not worth it. You got to first start with what Hubble does. So I know why you had to do that.
Yeah.
And so you geared a lot of it towards, what is a habitable zone? Why are we looking for planets with liquid water? Why does it matter? Things like that.